All right. So sorry, you guys are gonna have one longer recording and discovery and then probably a shorter one. Um, oh, what happened there? All right. So let's go to our lab number two. Hmm, there we go. So, two. Oops. Oh, I remember. This is a beauty. I remember this one. This is a good one, Haven.
Yeah, I filled out the chart values, I think, like all of the individual calculations, and then tried to create what I thought was the EOQ chart, but then don't know what like draw curves mean and not confident I have the chart correct either.
Okay. Yeah. So on exercise three, so these column headers, I sort of gave you the hint how to do the calculations, right? To fill these out. Um, but what you'll find is that to draw this, basically, you're going to, let's see, I think you're going to highlight all of these, right? So you're gonna graph all of this.
But just like the D through, you said D through G, I think, or it says using columns D through G,
Okay.
or did you want us to include C and
Yeah, I
E
think we need
too?
to include C as well, because so I'll show you in general. I won't like reveal the ultimate answer, but I'll show you in general what an EOQ set of curves look like. Which, by the way, are you guys familiar with what an EOQ is? Economic order quantity. It's actually a really cool thing. So about 100 years ago, I believe it was Franklin, or excuse me, um, Frank Winslow Thomas, right? Mr. Scientific Management. He basically was an engineer and said, "Hey man, we need a methodology and a model to help us determine, given several different assumptions, how much we should order of a given part or parts, because we don't want to have too much on the shelf because we're tying up cash. On the other hand, if we have too little on the shelf and we run out, then customers get mad because we don't have what they came to my store to get." Okay. So um, he developed that EOQ model to be able to help us deal with that. And again, that was probably about 100 years ago. So if we look at that, give me a graph. Here we go. All right. So this is what the graph is going to look like, Haven. Okay. Yeah. Well, whoa, for some reason, my Wi-Fi is not behaving real well. All right, we can look at this one here. Can you see that okay, Haven?
Yeah.
Okay. So basically what we've got, right? So we're going to have a scale problem. Okay. So we're trying to map our holding cost, our order cost, and what we're trying to do is we're trying to figure out um, what is the quote optimal number of units that I should order at any given point in time. Okay. So I'm trying to minimize my total cost here. So you can see this total cost curve. This is the minimum. And well, where does that occur? This is a typical kind of microeconomics analysis. Well, where's the optimum? Well, it's where two curves cross. So where my ordering cost equals my holding cost or my storage cost, that is going to define if I take this intersection and I go all the way down to my x-axis where I'm mapping quantity on this x-axis. That's going to tell me the number of units that I should order whenever I place an order. And so the context for that, you might be like, well, who the heck cares about EOQ? Well, you might remember during COVID lockdown, even in the summer, I think it was what, 2021? Summer 2021, where there was a lot of concern because all of those containers that we were talking about a few minutes ago, they were all sitting off the coast of California and there weren't enough trucker people to unload all those container ships and get all of those containers on tractor trailers or on trains and get, all those wonderful toys that Santa's going to bring on December 25th. And so if you are a VP of marketing at Walmart in July, you're like, oh my gosh. I got to make sure that I got enough of these Game Boys or whatever on the shelf so that, I don't lose hundreds of millions of dollars because I'm in a stock out situation. I don't have anything on the shelf. Um, and so that provides a bit of a context for this idea of supply chain management and how do I manage the amount of product that I'm going to have on a retail shelf or sub-assemblies of parts where I'm assembling a finished good. Like, for example, a couple hours away from here is the Corvette assembly plant, is really cool, right? But they don't actually, they take all the sub-assemblies and they put them together. But if some of their sub-assemblies come overseas, let's say, and it was during COVID, and a bunch of their stuff comes from China, well, guess what? Dealers aren't going to be getting Corvettes because they can't assemble them because they don't have a bunch of parts. So that's sort of the context of this economic order quantity is I need a methodology to help me balance the amount of cash I'm tying up um, in sub-assemblies or parts versus ticking off a bunch of customers and losing sales because I'm not able to supply the demand for a given product or products. So, does that make sense? It was a long answer to a short question, but hopefully, seeing the picture of these, what an EOQ kind of chart would look like, will be helpful so that as you fill out this table, you'll start to sort of know, like when you buy a puzzle, if somebody throws away the puzzle cover, you got problems, right? Because I don't really know what I'm supposed to be building. We sort of know, okay, the chart should look something like this. So when I do all these calculations, right? Demand divided by quantity, and I fill all that out. Same thing, D divided by Q times S, so on and so forth. Now, when I have done all these calculations, I know that my chart should look something like this. Does it make sense?
Yeah, I guess we solved for the EOQ with that like formula. How do
Okay.
we get that to be inputted on our chart, or do we need that input? I'm assuming we need that on our chart.
Yeah, well,
Um,
yeah. So what'll
or like where
happen
does
is,
that number come in?
yeah, so this here's our EOQ formula, right? So we've got that. All right. That'll tell us what this number is. And so that number will be this value right here. Okay. So when you calculate this EOQ number, whatever your answer is, that will correspond to this place on the chart. Okay. And y the other thing that
Wait,
you'll
which wait, will it draw it for us, or are we supposed to input that
No,
somehow?
no, you'll need to draw that. I mean, but basically what you'll see is
Oh, okay.
that all these curves will cross. And then if you were to take a ruler, if let's say you printed this, which you wouldn't, but if you were to print it and you took a ruler and it was square to or is parallel to the edge of the paper, you would draw a line down and go, oh, okay. So that's the number of units I need to order every time because I've taken the minimum of this total cost curve, which corresponds to where these two curves cross. And I've, drawn a straight line all the way down perpendicular to this x-axis. And that tells me what that should equal that number right there. Okay. So probably what I would recommend is I would fill out this chart. Okay. And I basically given you the formulas. Okay. And then I would draw that. I would highlight, I would highlight actually C all the way to G. I would do that. And then I would draw a curve that will end up looking something like, or draw a chart that will look something like this. And then separately, you can use this formula to calculate this number. You will get a number. And that number should correspond to if I drew a perpendicular line all the way down here to this x-axis, that should look really close to that number that you'll calculate there. I think this is
Sorry,
one
I
of
have one more
those.
question.
Sure, go ahead, please.
So, are there going to be then four lines on the EOQ chart because
Yeah,
it's going to
so
have like batches per year, annual order cost, holding
yeah,
cost, and total cost?
yep, yeah. So you're gonna have here's
Okay.
your volume, here's your volume right here. Okay. That's gonna be your x-axis. Okay. Then you're gonna have your batches per year. That's demand divided by quantity. Um, then you're gonna have you've got this curve, and this curve. So you're going to have your storage cost, right? That's going to be this column. Okay. You can see that's linear and going, it's linear up and to the right. Um, you're going to see this total cost curve, right? I've got a denominator here, right? I've got uh, this plus this, or excuse me, I've got this divided by this times this plus quantity divided by two. Basically, what happens is that is this convex curve where it'll go down for a period of time and then it will go back up. And then you're going to be drawing this holding cost, which will be, or your order count, excuse me, I'm saying this wrong. Here's your order cost, right? That's going to be this curve, which basically goes uh, down at an increasing rate and then basically smooths out and becomes linear over time. The storage cost is linear all the way up and down. And then this total cost is a convex curve where it goes down to a minimum and then will go back up. So, um, I, I'm probably muddying the waters and I don't mean to. I would recommend, excuse me, I would recommend filling out this chart using these formulas and then trying to draw the the curves. And then if it doesn't look like this, then let me know. And then we'll figure out why. And it's probably a scale problem, similar to
Yeah,
lab.
all of mine are going the same directions.
Okay. Yeah. So probably we've got to put one of those curves on a secondary axis and then it'll look right. So a lot of times what happens is when people don't do that, all of the curves basically go down to the right. They go, whoom, they go down to the right, like, it doesn't look anything like that. Well, what we got to make sure, right, is these numbers are very different in scale, right? The 2000 and 4000 are a lot bigger than 336, right? So in order for the curves, the chart to look like this, you've got to plot certain curves on a secondary axis. Remember, like we did in Lab 1? Remember how we did that?
Yeah, that makes sense.
Yeah. So yeah, if we go back here to Lab 1, we had to go, what? No, I mean, so, right, we had to go, um, format data series. If we left it on primary, you're like, I don't know what's going on there. I'm not really seeing anything. Okay, well, the number of hours online, 8 is a lot different than 500. So, okay. Why does that look weird? Well, it's because I got to plot that on a secondary axis. Now I can see the relationship between the two curves. Same kind of thing here because the total cost, those numbers are a lot bigger than the number of units that are ordered, right? And we can sort of look at that. We can go, huh, yeah, 4,000 and 2,000 are a lot bigger than 336. And so I have to draw, I can't draw all four of those variables on the same axis. I have to separate them so that I can see what the real relationship is because of that scale problem.
Is there a way of determining which ones, like just from the top of our head, which ones we think should move, or do we just try them out until?
Well, no, I mean the way I would do it is, if it's a big number like, demand or order cost, those are in thousands. I'm like, okay, I'm going to read those on one axis. And then the smaller numbers, I'm going to read those on another axis. Does that make sense? Because if I don't, then I'm not able to see what's going on. I'm not able to determine. I'm mixing like apples and giraffes. They're just completely different. So, but I would just say do these calculations. I'm making it sound like this is fourth semester calculus. It's not. I mean, this is pretty basic, but what I would say is that once you do these calculations and you're able to fill in the correct values in each one of these cells and then draw a chart, and then if it doesn't look like that, then let me know and we'll take a look at it. Okay. And by the way, there are no dumb questions. I know that's the classic thing that any teacher would say, but there really aren't. And so, if you're working on this and you're like, hey, Dr. Ross, wait a second, I'm not seeing what's going on. Let me know and we'll work on it together. Okay. Any more questions about anything? Did I put everybody to sleep? That was like, now time to go night night. Yeah. All right. So for the supply chain nerds, if you really want to get into the weeds on EOQ, there's some really cool stuff out there, sort of around the theory and how um, scientific management sort of birthed this EOQ, and I think it's pretty cool stuff. So. All right. Well, if there's nothing else, these are recorded, this one, and then we had the interruption, the one before. Once those we're done, I'll put them in Discovery, and you guys can obviously look at those, and anyone can at any time. And then I think, was it you, Renner? It was an excellent question. Hey, how long am I supposed to be in a death match with Excel before I kind of cry uncle? And I would just say, I said an hour, hour and a half, but if you're like 15 minutes into it, you're like, man, I got no idea, then that's okay. Just reach out, and I don't want you guys to be, breaking your pick, as it were, when there might be a couple little things we can do, and we can get you on the road quickly. Okay. Does that make sense? I really appreciate you all. Haven, you must be a strong lady. You're surrounded by some strong men here, so you're holding up the flag here of the female persuasion. So way to go. Now, are you
Trying
in
to, trying
Texas,
to.
or are you still in
Yeah,
Texas?
I'm in Texas, but I leave tomorrow, so I'll be in Kentucky tomorrow.
Oh, well, cool. I'm trying to think if I'm going to be. I'm not sure I'm going to be on campus. I'm going to be off campus in the morning, and I think I got some stuff off site tomorrow afternoon. But definitely stop by if you happen to see my door open. I'd love to see you. So, well, you guys have a great evening. Thanks a lot. See you soon. Okay. All right. Bye bye.
Thank you, Dr. Ross.
Got it.